Welcome to the Walton Pi. Today we're going to go through some examples of inverse functions. Alright, let's get started. So, an inverse function is a function where f inverse of f of x for any x. In the domain of f. So, for example, let's say that f of x is equal to x cubed. Then f inverse of x is going to be the cube root of x. Because if we look at what is f inverse of f of x, well, that's just going to be the cube root of x cubed, which is actually equal to x. So the inverse of x cubed is the cube root of x. Now, if we're looking, let's say that we are looking at g of x is equal to x squared, and we're trying to guess what would our inverse function be. Well, we might guess that g inverse of x would be the square root of x. However, if we look at what's g inverse of g of x, this is the square root of x squared, but this is actually equal to the absolute value of x. So this is not going to be the inverse over all real numbers. This is the inverse only of x that are in the interval 0 to infinity. This is only an inverse for positive or non-negative numbers. So that's one of the things that we have to care about, and this is why in the domain of f is going to be an important part. If we restrict the domain of g, in this case, just this interval, then yes, we do have an inverse. But if any negative numbers are included as well, then there's not going to be an inverse for that function. So let's go through and figure out what would an inverse be for some other functions. So let's say we have y is equal to 3x plus 2 divided by 7x minus 1. One of the first things we have to check is what's going to be the domain. And so in this case, it's going to turn out that our domain is just going to be x cannot be 1 over 7. Because in this case, we would have a division by 0. So if the domain is not 1/7, let's go through and try and figure out what the inverse function be. So we are saying that f of x is equal to 3x plus 2 over 7x minus 1. So if we start with this, the way that we can find the inverse is we solve x equals something by itself. So to start off, let's try and figure out how might we be able to get x by itself. Well, let's see what we can do. Let's see. Well, let's start by multiplying both sides by 7/3. You might be wondering, why are we multiplying both sides by 7? Those are the coefficients of x in opposite order. And this is what I'm doing this, and that will make it easier for us to be able to pull the x's out by themselves. So we are going to get 7/3 y is equal to 7 over 3 times 3x plus 2 over 7x minus 1. And so that is going to give us 21x plus 14 over 21x minus 3. And so this is actually going to be pretty helpful, because we can x plus 14 as 21x minus 3 plus 17 all over 21x minus 3, which means we can break this fraction up into 21x minus 3 over 21x minus 3 plus 17 over 21x minus 3. Well, that tells us that 7/3 y is equal to 1 plus 17 over 21x minus 3. Why is this so important? We now only have a single x, whereas before we started with two x's. This makes it a lot easier for us to be able to isolate that x. So what we're going to be doing is we can then subtract 1 from both sides. So we get 7y over 3, 1 is equal to 17 over 21x minus 3. Well, 7y equal to 7y minus 3 all over 3. At this point we have two fractions are equal to each other and we are trying to isolate the x. One thing we can do is we can just flip both fractions. So that tells us that we get 21x minus 3 over 17 is equal to 3 over 7y minus 3. Multiplying both sides by 7, that's going to give us 21x minus 3 equals, let's see, 3 times 17, that's 30 plus 21, so that's 51 over 7y minus 3. Adding 3 to both sides, that gives us 21x equals 50, whoops, not 15, 51 51 over 7y minus 3 plus 3. And then what we can do from here is we could combine the 3 with the 51 over 7y minus 3 as saying, well, that's going to be equal to 51 over 7y minus 3 plus 21y minus 9 over 7y minus 3. So that gives us 21y. Let's see, 51 minus 9, that's going to be 42. All over 7y minus 3. So we got 21x equals 21y plus 42 all over 7y minus 3. Dividing both sides by 21, that gives us x equals y plus 2 over 7y minus 3. So that tells us that we are going to have our inverse function is going to be x plus 2 divided by 7x minus 3. So if we go back to figure out what our original function f was, that was 3x plus 2. So let's grab that and bring it over. So let's see if these two functions actually are inverses. So let's see what happens if we look at f inverse of f of x. Well, that's going to be, we are going to put f of x everywhere where there's an x in our f inverse. So that's going to be 3x plus 2 all over 7x minus 1 plus 2 all over 7 times 3x plus 2 over minus 1 minus 3. Let's see, let's multiply the top and bottom both by 7x minus 1. So that's going to give us 3x plus 2 plus 2 times 7x minus 1 all over 7 times 3x plus 2 minus 3 times 7x minus 1. Well, that is equal to, we have 3x plus 14x, so that's 17x. And we have a plus 2 and a minus 2, so plus 0. And on the bottom we have 21x plus 14. minus 21x plus 3. 21x and this 21x cancel. We're left with 17x over 17, which is equal to x. So that direction check. So this is the process we can go through to be able to find the inverse function of any sort of situation. You try and solve for the other variable. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.